Thank you very much indeed. That was a real marvelous rundown of health pollution interactions. I have a question from Professor Litta.
For this opportunity. I'm very grateful to give my little contribution in support of ethical and scientific reason for the reduction and the rationalize of air transport. I'm a medical doctor. I'm the national coordinator for Italian Medical Association for the Environment of the study group on the topic air transportation as a factor of the environmental pollution and damage to the health. You know, air traffic is an important factor of the environmental pollution and the health damage, and its contribution to climate change is increasingly relevant. We have to consider that during the last decades, air traffic has shown a continuous growth, mostly in respect to the freight sector and the low-cost flights, usually related to the so-called hit-and-run tourism. According to the European Aviation Environmental last year's report, by 2030, air transport contribution to the carbon dioxide emissions will be 17% on total emission of carbon dioxide in the world. Every day, more than 100,000 aircrafts take off, polluting the sky. This topic compels me to remember here, on this special occasion, what Pope Francis stated in his address to the participants in the meeting on economics of communion last February. He affirmed, aircrafts polluted the atmosphere, but with a small part of the cost of the ticket, they will plant trees to compensate for part of the damage created. Guiltily and very seldom, air transport is considered a sector to act upon to reduce air pollution and fight climate change, as unfortunately happens at the various international climate conferences. Yet it would be right and necessary to include in the improvements plans for air quality such actions and measures aiming to reduce and rationalize the air transport. Indeed, the emissions originating from aircraft engines using kerosene, a mixture composed by different types of hydrocarbons, are generally similar as to composition to those generated by combustion of other fossil fuels, but they strongly increase the greenhouse effects, for they are released directly into the atmosphere.
Can you keep this a bit short, please? Because it's a statement, not a question. So perhaps you could, we are running out of time.
Excuse me, could you repeat it?
I'm saying that this is a statement, not a question.
Not the question. Okay, so the question is, I'm sorry, because I didn't understand. The question is, how do you consider the air transport as a relevant source of pollution if we want to counteract climate change, environmental pollution? We need to reduce and rationalize air transport.
Thank you very much. Any other? Yes, indeed. Professor Haynes.
I'm sorry, could I follow that question with another question to Jos? Thanks for a great presentation, but you didn't mention methane and tropospheric ozone as an important pollutant. Methane, of course, is an important greenhouse gas, shorter lived than CO2, and is a precursor of tropospheric ozone. There's been a recent reassessment of the importance of tropospheric ozone as a pollutant, and it probably is responsible for about 1 million deaths a year according to this recent reassessment. So I wonder what your view of this problem is and whether it deserves more priority or prominence.
Do you want to respond to these two questions now, or do you want to take some more?
I'll be happy to respond. So first of all, air transport. Of course, this is an important source of carbon dioxide. In the areas of airports, it can also be an important source of air pollution, not only the aircraft, but also all the activity around airports. But on a global scale, this is a small contribution. Most of the emissions of non-CO2 emissions from aircraft as nitrogen oxides. They're being emitted in the upper troposphere, which is full of nitrogen oxides, actually. It comes down from the stratosphere and it's made by lightning. So I think, although I fully agree that these sources must be controlled, it's probably only a minor source globally in terms of air pollution-related health, although I do not want to play down the importance for people living near airports. The other issue is methane. About 1/3 of the ozone in the troposphere can be attributed to oxidation of methane. You would have to drastically reduce methane to get an impact on ozone. And as I've shown, and also other studies, that the health impact of ozone is of the order of 250,000 people per year. This is not a trivial number, for sure. But you would have to really drastically reduce methane in order to do something about this 250,000. So I think methane should be high on the agenda because it's a pollutant and a greenhouse gas that can actually help in the short term. And it's very efficient, actually, because there is lots of technology available to reduce methane emissions. And it certainly has the side effect of also contributing to less ozone. But I think the motivation to reduce methane is probably stronger from a climate perspective than from a health air quality perspective.
Thank you very much. Can I just interrupt? Just a quick question. I thought a great deal of the methane is produced from cattle, and that's not a technological solution.
Oh, yeah.
Am I right? Or?
Yes, that's right. I mean, with methane, you also have several sources that you cannot control. I'm sure you cannot control methane from cattle in India for many reasons. But actually, you can control methane from cattle in other environments, and also you can adjust what they eat so that they produce less methane. And there are many other sources, like fossil fuel-related sources, that can be effectively controlled. So methane is certainly a greenhouse gas that we should pursue.
Thank you very much. I think Ram has a question.
Yes, thank you very much for that excellent presentation. I will now read your paper. My question was, you raised an important issue about the cooling effect of aerosols. And I want to point out, and please comment on this, that if we cut air pollution without cutting the climate pollution, we could see an instantaneous warming of about 0.5 degrees. Well, that's my estimate from IPCC. That's why we are pushing hard for an integrated strategy. When you bring the air pollution lever, please bring down the greenhouse gas lever. Otherwise, we have a disaster. We can quickly go over 2 degrees in 20 years.
Yeah, couldn't agree more. This is something that will actually happen because many countries are interested in reducing pollution from fossil fuels, like sulfur dioxide. I mean, we just discussed it. It would be surprising to John and myself if Germany would not decide to get out of coal in the next decades. So these are the things that are going to happen. And the side effect will be is that it will release or unleash, as you call it, it will unleash warming. So we have to be aware of this, that, I mean, there are co-benefits, and the co-benefits are sure there. They're definitely there, but they're more in the long term. But in the short term, we'll have more warming. And at least from controlling air pollution.
I have 3 questions, and that's be all. Yes, sir.
First. General comment related to the 2 presentations and the use of burden estimates. And I think as a general comment we should think about, there's a difference between attributable and avoidable that in some countries is substantial. And the promise of 5 million attributable deaths, or this estimation of that, is quite different from the possibility of avoiding all of those deaths. And I think the use of these estimates should be scaled and made in a sense realistic to each context, and perhaps this is a general point for discussion to return to.
Thank you very much.
Yes, most of your paper focused on mortality rates, but I wonder if in the United States, Leo Transcende has published on PM 2.5 as a precursor to preterm births, and actually published around 16,000 preterm births happen in the United States because of PM 2.5. Do you have any numbers or statistics just on that, in looking at that as an attributable cause worldwide?
Actually, I'm not an epidemiologist. So I work with epidemiologists very happily, so we've learned a lot from each other, but they have not been able to train me on those things. So what we do is we very closely follow, say, the stage that is being set by the global burden of disease. So actually, maybe I can also answer the previous question, the attributable as compared to avoidable. This is exactly what we try to do, because it's, as you said, 4.5 million or whatever, they cannot all be avoided for sure. And they cannot all be effectively avoided. So we need these sorts of studies, I think, to find the lever where we can be most effective in cleaning up the air. Yeah.
Thank you very much. Jeff.
Thank you also for a really wonderful presentation. It's a number of technical questions. First, of the deaths, are they all chronic exposure, or are there acute? Is there a significant part that's due to acute exposure? And if so, would also daily monitoring and alerts not only obviously not only save lives perhaps if it's acute, as in these horrible days in Beijing, but also be, from an advocacy point of view, very important that people are watching day to day and they're understanding how dramatic this is. So just chronic versus acute. Second is whether the sources of the PM 2.5 make a very big difference. You said some are from dust, some are from ammonia, some are from carbon. Is it PM 2.5 as an irritant, or is it the particular chemical pathways that are important? Third, how confident are we about the attributable risk, actually? Is this mainly global burden of disease estimates, or is this really deeply established widely in the literature? And then the final question for me on, again, the masking of global warming. What do your models say about the magnitude of the effect? Certainly we're moving out of coal. To gas would be a disaster from climate change, but it is one of the trends. And so we're really likely to see a cleanup of the air, I think, faster than we're going to see a concentration effect. So it sounds to me like we're going to have that blip of temperature. Is that 0.1, 0.3? Could be extraordinarily dramatic over a period of 10 or 20 years, it sounds like. So like your quantification of that.
Okay. First of all, the chronic and the acute effects. What's being calculated here is what the global burden of disease is. Also, this is chronic, so this is long-term exposure to air pollution. But for the details of that answer, I'm going to ask Professor Samet to go into that. Then the sources of PM 2.5. Thank you for that question. That's, I think, something that most people are not aware of, is that the small particles are mostly made in the atmosphere. So the gases like nitrogen oxides, ammonia, sulfur dioxide are being emitted into the atmosphere. In the atmosphere, they're being transported and they're being chemically converted into particles. So that means that the primary particles, for example, the primary organics like black carbon, that's only a small fraction. So if you want to control the air pollution in a city, it doesn't make a lot of sense if you only focus on your own city to control nitrogen oxides, because the particles that are being formed from the nitrogen oxides is 1 or 2 days downwind. So you have to put this into the perspective. And the larger particles are often the primary particles, so they're emitted as particles. But the secondary ones, the small ones, they are the ones that get deep into your airways. Now, this attributable, how good is your question? How good are these results? I think it hasn't been done before a lot. I think in epidemiological studies, people have tried to correlate. So, for example, they said, okay, black carbon is a tracer of traffic, So we look how much black carbon is in the particle, and then we attribute it to traffic. But I think this is a road that has not been very successful. I think in the United States, studies have really shown that power generation from coal-fired power plants is a main source of illness and death. But I think this is pretty much the only source that has been more or less established in terms of proving which source is causing the problem. And here the problem is that the particles are being composed of many sources, and to disentangle the different sources is really a big problem. And I think this is where our models can be helpful. But again, I must say it's only a model. So we must find ways also to chemically attribute what's in the particles to the sources. And the last thing was on the temperature.
What did the models say about the size of a spike that is possible in say, a 10 to 20-year perspective?
Yeah. Well, actually, one of the real bad guys is sulfate in this respect. Sulfate is a cooling agent. And as soon as we get out of coal, I mean, like in China, is actually now carrying out a huge cleanup program. Since 2010, the SO2 emissions in China have halved. It's amazing. So they are equipping all the power plants with filters that are effective. But we should realize they can maybe take out maybe 80% of each individual power plant, and the rest of the 20% cannot be taken out. And I also mentioned India. India, things are being totally unfiltered in the air. And there actually the growth of air pollution related death in India is mostly because of coal use. The coal use in India has doubled in the past decade. So I think in terms of temperature, if we start, I think Ram mentioned the number of 0.5 degree. I think this is pretty much what IPC itself, if you look at the reports, you will see, the scenarios. If the fossil fuels have been taken out, the first decades or so, the temperature is going up, and then it will be going down. So it's not something new that we're telling here. It's known. But we should realize that if we clean up the air, the short-term effect will be warming, and the long-term effect will be climate change reduction.
Thank you very much. No, I think we have to move on. Thank you very much. That was a great presentation and a great subject.